Right. First of all, I do apologise. The mic is stuck in Amsterdam, I believe. I'm trying to remember the name of the appropriate road there, but I got the one in Hamburg instead of the one in. But hopefully he will have sorted that out. But I would, in any case, like to put on record our thanks to Mike for making this venue possible, and we're very sorry that he's not with us here today. Right. Okay. Normal DDS. I don't know. It took me some time to get into DDS. I don't know if you remember, some years ago we were given a chat about MBE21, which was going to be the great thing for all the microwave beacons and so on. And I did attend a number of discussions with various people. Grant, are you here tonight?
No, he's testing for the moment.
Is he? Right. It all went way over my head, and I think it gradually turned into MBE22, and still there was nothing actually on the air. But as you know, Andy has done some interesting work, particularly on the South Coast repeater beacon complex. Sorry if I talk about repeaters and beacons, it's just that it's getting late. When I started to realise, and others started to realise, with a lot of help from Chris, JBKE and John, that this is a good way to solve one of the problems that we've got with beacons. Beacons tend to wander a lot, and the reason they wander is because we're too mean to buy decent quality crystals. In fact, it's quite hard to get decent quality crystals. So some of them wander quite embarrassingly. Now, how could we solve it? The MBE21 route, they were looking at direct digital synthesis, where you take a reference, typically maybe 100 megs, which is probably multiplied up in the DDS chip. I won't go into great details because you can pull down the data sheet from analog devices. We're probably talking about something like the AD9852 here. The division is determined by a frequency tuning word, which is generally loaded from a microcontroller. So that's the way a normal DDS works. So you have a reference, from that reference you process it and turn it into a more or less sine wave at the output at a lower frequency than the reference itself. And you control it with a microcontroller. With a Reverse-DDS, you don't do that at all. You have your normal OCXO with your normal crystal. This can be retrofitted to an existing beacon, so it could be an already existing OCXO which has got VariCAD control on it. And you use that to clock the DDS. So not 100 meg reference clocking it, the actual oscillator that we're going to use, and there's the output going off to the rest of the beacon. So that clocks the DDS. Now, the frequency tuning word we put in there processes the clock frequency to generate the reference frequency. So what we're trying to generate here, in this case with a 10 meg reference, we're trying to generate 10 megs. Simple. Then we phase compare and use the different signal to control the clock. So we're using the DDS, if you like, back to front, but it's controlling the OCXO. Everybody happy? Right. I'll just talk you around the circuit a little bit. I don't know, can you see any of this, or is it too faint? It's just roughly talking you about it. We've got a PIC here that contains the code to set up the frequency tuning word to get the frequency you want. It probably also, if it's a beacon, it also contains the keyer. And it is busy sending the frequency tuning word to the DDS chip. Here we've got the output from the OCXO is just looped through here, and a sniff is taken off, buffered, and is put into the to clock the DDS. So that's your 100 megs odd signal that you're using, that you want locked, comes in there. Here we've got 10 megs comes in. We're using you might call it a mixer rather as a phase comparator. A little bit of filtering, jiggery-pokery, that comes out and controls the OCXO's varicap tuning. The PIC, we designed it so that the PIC has got various expansion possibilities. We've got an expansion port there with various I/O on it, so you can make it do other things. And the whole concept of what John and I have done was to produce a board which we hope is versatile and will encourage you to do other things and improve the software and develop the software further to do different things. It might be as a signal source for the shack. We'll talk about that a little bit more in a moment. And that the facilities can be extended by anybody who's interested, because indeed we put, oh, sorry, let's go back a bit. Go too far. Slight latency here. That header there, if anybody's familiar with microchip development tools, the PIC can be plugged in there to program the chip-in circuit. It is socketed as well, so you can program it using your favourite PIC programmer if you like. Right. So here is a little bit of a jumble of the equipment we've used. Originally, John made a prototype board using his laser printing method. I'm amazed that he can produce sufficient resolution for the type of chip that the package that the DDS comes in, but he's got the technology, and we did lots of work here. You see it locking 124.5 meg OCXO as a local oscillator for 24 gigs. You can probably see the spectrum there looks reasonably clean. A couple of little spikes there, which were probably more to do with the fact that I've got it wired up rather badly and the covers are all off. But pretty clean signal. We'll talk more about that in a minute. This is one of the advantages with with RDDS over DDS. Direct digital synthesizer generates a lot more grass, and as you multiply it up, that grass gets longer and longer to the point where it's not really very usable on microwave beacons. Whereas this, the grass is no worse than your normal OCXO, clean OCXO, and the signal is very nice and clean. We'll talk about that a bit more in a minute. That's the picket. If anybody is keen on doing any work with PICs, I can recommend it. I used to work with PICs a long time ago, and my equipment was all out of date. Andy suggested purchasing a picket, and you get all the software. This gadget here, which plugs into a USB port, and you get that board as a demo kit. I haven't actually got stuck into this board, but it looks like a very interesting board to play with. I was just simply using it to program the 16F628, which is what we used in the RDDS board. And that header there plugs onto a row of pins here for in-circuit programming if you want to do that. A little bit of a look around the circuit board itself. Here is the loop through for the OCXO. It just simply comes in, a snip is taken off through the buffer and in to clock the DDS. 10 megs or whatever reference, I should explain that. You can use any reference you like that's stable and clean, because you can calculate the frequency tuning word to generate that frequency from whatever your OCXO is, and there's a calculator to do this on my website using a spreadsheet. You can use certainly a reference between 5 megs and 20 megs. And if you've got a wonderful 10 meg reference that you can't quite get onto 10 megs, but in every other way it's perfect, that's fine. You put the number into the calculator and it will calculate the tuning words, and you can lock to that and still be on frequency. So that's the busy side of the board. The other side of the board has the PIC, an expansion socket there which makes it versatile. The other thing one should mention, and this is a very good feature that Andy provided on his system, there's a 3-pin header that is actually an RS232 port. And you can connect that up. If you have an RS232 port connected at the time of powering up the DDS, it goes into programming mode, and you can reprogram the frequency tuning words if you want to. We'll perhaps come back to that in a minute. As I said earlier, the great advantage of RDDS versus DDS is the cleanness of the signal. Here you've got a 50 megahertz span at 2.5 gigs, and that's as good as my spectrum analyzer can do. Very, very clean indeed. We'll look at some other ones in a moment. There is an issue. The issue is resolution, particularly as you go up. If you have a 10 meg reference at 24, by the time you get to 24 gigs, one bit of change in the frequency tuning word corresponds to about 66 hertz. So you can get your beacon on frequency within 66 hertz, provided your reference is good.
Right, within 33 hertz. Makes a difference, JT. It's half a scale.
Okay, right, fine. I stand corrected.
It's not very good then.
Here we are having a look now at 10 gigs, and I think you can see there's very little change. And in fact, I have to say that when I took that shot, it was probably keying at the time. We had some trouble there in the test earlier. We were wondering why it was doing this, and you've got a 10 kilohertz span, and we were wondering why it was jumping about while it was keying at the time, so it was not entirely unreasonable. So quite a nice clean spectrum. And going in a lot closer, 100 kilohertz span there. I mean, we're looking at the noise characteristics of my spectrum analyzer rather than at the system here. Last night we did an interesting test which was witnessed by a number of folk who are here today, with 30 milliwatts pointing straight at my EME system, and as it happened, there was about 10 kilohertz of Doppler shift, so I transmitted more or less on the beacon frequency. I think it was about 9 kilohertz, wasn't it, the Doppler shift when we did it? And we could hear our echoes 10 kilohertz away, so pretty clean.
What area was the 30 milliwatts into?
It was an open waveguide pointing at the 30 yards from the dish. Of course, the dish wasn't pointing at it, but I can assure you the S meter was wrapped around the end stop, and indeed the noise power measurement, which I normally use to detect the moon, would have been off the end scale as well. This, by comparison, is a signal generator at 12 gigs in this particular example, generated using an AD9852 by direct digital synthesis. And you can see, I mean, we're only looking at 100 kilohertz. That grass, as you see, is at a rather higher level, and it goes on more or less forever. Any comments on that, Andy? I mean, that's not unreasonable, is it? It's what you expect.
It sounds horrible.
It's what you expect, though, isn't it? Sadly so. Direct DDS, not the answer for particularly the higher microwave bands. This is an example of how you might use it in a beacon application, and you've got here your OCXO with the normal pot that you would use to set it up on frequency, so you can set it up nearly on frequency with, say, half the supply or half of that voltage without the DDS connected, 100k resistor onto the control line, and then when you connect the Reverse-DDS, and it locks, you should have no volts across there. You can, if your beacon has been headed north frequency-wise, then it might be wise when you set it up to set this a bit south, so that it's got plenty of room for moving the control voltage to compensate as the crystal ages. Talking here about the Reverse-DDS, there was one little mod we had to put in we found that the loop could become unstable because we very unwisely, well, we've got feed-through capacitors here and here, and they tend to be very variable in the amount of capacitance, and if they were too much, it made the loop go unstable. So we needed just an extra 100 ohms or so in series with the output from the op-amp. The other features we've got here, we've got A1A keying available, which can drive a, I would suggest the best way to do it is to drive an octo-isolator, so you've got voltage-free contacts to do your keying with whatever else you want A1A keying on. The frequency shift keying, obviously, that's not relevant, but we also have another bit from the DDS, which in the program acts as a delay timer. So if the power goes off and comes back on again, it waits for an amount of time that you can program. You can set that in E2 ROM, say 15 minutes, which is time for the OCXO to warm up and the reference to warm up before it switches on the rest of the beacon, so you don't get the swooshing bit. Of course, it's an OCXO anyway, so it's not likely, and the capture range is quite small, so it's not going to go out of band, but it might have been unlocked while it was warming up, which is not such a clever idea. If you're using a typical sort of indoor unit with that in the indoors and the outdoor unit being multipliers and so on, you may want a bias T, so you might feed the power to the beacon up through a bias T. When we did the first installation, or what's nearly the first installation at Farnham, we found that this point was rather sensitive to noise from the switch mode power supplies, which had been entirely clean up until now. At least we assumed that's what it was, and we did find we had to add a capacitor actually at that point. I've got it in the wrong place, I think. No, it was that point, that's quite right. Because it was getting onto this line, and that's quite a sensitive point to put rubbish back into the RDDS. And those of you who've listened to the LEX beacon, which is not Jeff, are you here? That man there will zap him with a laser. It was unfortunate that I didn't think we were going to get access to the beacon, the Farnham beacons, to test the first ones ourselves. So Jeff very kindly volunteered to put the LEX beacon on. I thought so potentially he was the first one, and any problems were going to appear there. Now originally I was planning to go up there and be with him and feel the pain, but in the end that didn't happen, and so it's making horrible noises at the moment. Apologies for that. I'm sure we will solve it, and it will probably be a case of something like that capacitor there needs to be fitted. At least it's on frequency, but it doesn't sound very nice. Okay. The other, what have we got here? Right, okay, so this is some of the beacons that we've programmed up, and it's just a screenshot of the calculator, the spreadsheet which calculates the frequency tuning word. There's the frequency tuning word in decimal. My copy of PowerPoint, because it's ancient and I haven't got the disk for it, doesn't have the dec to hex function, so it's not shown there in hex, which is what you needed to code up the PIC. The other configuration, and the configuration that will get shipped if you buy one of these kits from John, G8ACE, the configuration that will get shipped is with the local oscillator coding, not beacon code. Excuse me, I'll just have a slurp here. It will get shipped with the local oscillator version, and this is really just an example. It's not a terribly good one, but you could, for example, have 4 different local oscillators. In fact, it will cope with 16. You have 16 different local oscillators, and switch them through the RDDS, and it will control one of them at a time. The exact amount of switching that you need to do and whether you get away with a wafer switch or whether the crosstalk between multiple oscillators all running in the same box, that's for you to find out. But it's certainly possible to do that. And there are 4 I/O lines that we take out, which you can code in binary. If you only want 4 of them, you don't even have to use binary. You can just put a simple switch to ground. But you can have 16 different frequencies, and here's the table. You've got the tuning word in hexadecimal there as well. So we've programmed into it. Remember, you can change all these used by just connecting an RS-232 port, but we've put in 76 gigs with 144 meg IF, 432 megs IF, 47 with 144 or 432, and so on, and so on, and so on. And you'll find I've repeated some of them because I simply ran out of ideas of what local oscillator frequencies. But we had one particularly difficult customer, John, who wanted 1296 with 1 kilohertz offset, and you just do that, no problem. So you program it to do 1 kilohertz offset, whatever you want. So a very, very flexible arrangement. I don't know how many of you got to hear the demo that was running out there, but in the other place. But I threw together, I must have spent minutes on it, this VFO, very loosely coupled to a varicat, running at somewhere around 108 megs. And although it's a bit fickle on the tuning there, you can get it to lock, it does lock, and it produces a T9 note. Don't ask about the spectrum there, the noise, phase noise and so on, it's horrible. But as an in-shack signal source, it's very good. And I think that if somebody who's an expert on VFOs were to take one of the RDDS kits, build a decent VFO with some kind of much better frequency determining component there than a piece of old wire which you stretch and squeeze, and with something with a much higher Q, I have every reason to suppose you could get quite an acceptable signal out of it. Perhaps not, perhaps only for the lower microwave bands, or as an in-shack. Sam?
Yeah, I was going to say, I need to do this for MHX before we take it down. I looked at that and I thought actually another possibility is the 2001. If you don't crystal control it, but put the VCO, the varicat modification that John described, then you've actually got something there that you can control, and you've got a series of multipliers up to 1100 volt or 1200 megs. So all one neat little box if you needed something like that as a test sources.
Yeah.
A ready-made PCB at least.
Yes. Well, I've got a couple of these RAL synthesizers which have been totally unreliable, and they take up an awful lot of bench space, and I'm looking forward to throwing them out, having something like that with a DDS, an encoder type switch that you can wind the frequency tuning word up or down, and the display will be my frequency counter. And I've got a El Cheapo small, not much bench space signal source that I can use to run somewhere in the range, shall we say 90 to 140 megs. When you want a signal to tune something up, there you are, you've got it. And let's just see what else we've got. And that's it. So, any questions?
It strikes me that if you can control several VFOs and you can write different words, you could get much more than 90 to 140.
Yes. I'm hoping that somebody will go out and spend some money. I mean, we've been developing this, no expense was spent, I assure you, this one. But I hope somebody will go out and look at what VFOs or voltage-controlled oscillators are available and do some work on that. I'm not suggesting for beacons, because the danger is if it goes out of lock, it could go off into the nether regions. Although it's easy enough to make a lock, out of lock circuit, we have that already on tap, and anybody who feels it needs it. But we felt that with a OCXO, it's actually unnecessary, because it's not going to go out of band. It's only going to go 10 kilohertz.
Are the facilities to put PEC to sleep?
Absolutely, if you want to. The original design, Andy's original design, did put it to sleep, but the keying was done externally. And this one, we put the keying in. We had great trepidation that when we left the clock running all the time, that we'd have sproggies all over the place. And believe me, when we started doing this, John and I, we did have sproggies all over the place, but they were nothing to do with nothing to do with that. They were due to the fact we've got grotty old pieces of coax and we've got megawatts of 10 megahertz reference floating about the shack, and everything else was on the boil at the same time. When we actually screwed the lid down, tightened the SMAs up, there's no problem at all. But no, surprisingly, we've seen no trace at all of the PIC oscillator.
Nothing gets out.
But certainly, and the local oscillator version, it goes to sleep. Or when you change the selection on those pins, it wakes up, loads the word into the DDS, and then goes back to sleep again. So you certainly won't have that problem there. But with the other one, we wanted the keyer in there as well, so we had to keep it alive. JT4. Now, there are two competing teams here competing to put JT4 onto this. There's no reason in principle why, for a beacon, you should not put JT4 in there in addition to the keyer. And Andy's working on it, and Robin's working on it as well a bit. So we'll see. And the best way to find out who's going to get there first is fight. Exactly. So yes, it'll be hard-coded into the program, part of the program, as is the CW at the moment. The CW ID is hard-coded into it's not in E2ROM. Somebody might like to write the code to put that into E2ROM, but for Beacon, I can't really see why you would want to do that.
And you've only got 80 bytes to play with.
Yes. Any other questions?
Okay. Obviously, if you're going to put FM modulation modes on, you're going to have quite a quick loop filter. Is it option to put a long, slow loop in there so you can put GPS on it? So to have a separate loop to stabilise the GPS.
You were talking about putting what, voice AM or something, or FM?
No, GPS on reference.
Oh yeah, there's no problem with that. I mean, normally, it's a good point you've raised. We've been using this either with a GPS reference, such as the RUH one, which works fine. I mean, it comes up and it locks and does its own thing, which is very slow. 15 minutes or so it takes to get up steam, the RUH one. But there are a lot of these OCXO or TCXO references around on the surplus market, 10 meg ones, sometimes 5 meg ones, sometimes 8192, and all sorts of strange numbers. And I've been given various boxes of them to play with, and I'm surprised how good they are. We have got used to such lousy crystals that we've forgotten how good crystals can be. You know, if somebody sets up to make 10 meg 80 cut crystals of quality, they can churn them out, and they're very good quality. So when you go to Mr. Corpse Lab or somebody and ask him for a one-off 108.0100593, then I'm afraid it's going to go walkabout. So GPS, for beacon operation, I would suggest that if you've got GPS, that's great. And if you're going to do JT, you've got to have time from somewhere. So you've probably got to have GPS, or we hope that another keen person will come up with a solution using the guts out of a cheap digital radio clock to give us time. That would be nice and cheap and cheerful, and then you could use a nice and cheap and cheerful 10 meg reference. So I hope lots of people will play lots of different tunes on this thing. That's where the whole thing, as far as I'm concerned, is in the public domain. The source code is on the web page. Bear in mind when you look at it, if I believe it, I don't know, have they changed the theory about software that the longest piece of code ever written with no errors in it was 3 lines?
That's rubbish.
Well, so, if you can find 3 lines of my code that's got no errors in it, I'll be very happy to hear about it. Yeah, we hope people will play lots of different tunes on it. do different things. And talking about tunes, we did, as a bit of a joke, I should have really brought the demo along, but this talk was done at the last minute. As a bit of a joke, with musical direction from Robin, we did code one up to send Colonel Bogey. And I'll tell you something, that if anybody will, I'll perhaps put the recording on the website. But I left this running while we were doing various testing and so on, and I was amazed to find that when it's right down in the noise, Colonel Bogey is surprisingly recognisable. By ear, and I did suggest, I think, to Graham and via Sam, and apparently the prospect went down like a concrete parachute, that perhaps this was the future for identifying beacons, because Graham has always said they should have character. Yeah, absolutely.
But we should perhaps consider the Lincolnshire poacher.
In fact, you could get Coca-Cola to sponsor it, couldn't you?
Well, Brian, for the one that's going to Dallas, you did get the message that they wanted Stars and Stripes, didn't you?
Oh, right, yeah, no problem.
Radios are on a EQ
There is actually a problem on it at 10 gig.
Yeah.
The higher you go, the resolution of the frequency you can actually shift it to.
Yes.
It's stepping in, what, 16 hertz, is it?
Yes, something like that.
And if you look at the musical scale around the middle of the keyboard, little c, then your semitones are very difficult to hit without being sharp or flat.
I can tell you that it was, I had to explain to Robin that I wanted to know the notes of Colonel Bogey, and it was no use giving me sheet music. I needed it in hertz. That's what we did.
Is there enough difference?
It works far better at 23
You'll be able
shows.
to drop down to 10 kilohertz as the reference.
Sorry?
Is
The GPS side of it, what do you mean to lock your 10 megs with 10 kilohertz?
well, to actually use the reference, go in, use the 10 kilohertz reference. Can you go straight up the Duke's board?
No, I wouldn't. I would certainly not. I mean, it's something to try, but I would have thought you need to be higher up. The extent of references that I've actually tried are 5. Well, I think I've tried 4 megs and up to 20 megs. So anything in that range.
DDS would give 10 kilohertz out to change the transport.
Yeah.
I thought you wanted a fairly high
Thought you
rate.
could
Yes,
have
right.
Well, yeah, okay.
Your resolution goes down, doesn't it?
No, the resolution will go up because your end value will go up.
Yes, it was. I put the resolution on the spreadsheet and it was going the opposite way, which I thought was counterintuitive. So the maths must
By
be
going
wrong.
to a lower output from DDS, you're... No, okay, yeah, resolution will go up.
Well, according to my spreadsheet, it goes the other way. But you know, as with my PIC coding, you use it at your peril. Anybody wants to change the spreadsheet, that's fine. Anything else anybody wants to raise? Okay, I think that's about it.
Just one more.